In this module, I would talk about DNA sample collection and handling. After learning this module, you shall be able to understand the type of evidence material from which DNA can be extracted, the method of collection and preservation of evidentiary material, method of packaging and transportation of evidentiary material. As you know, DNA collection and analysis gives the criminal justice system a powerful tool for convicting the guilty and exonerating the innocent. Only 1/10 of a single percent of DNA, about 3 million bases, differs from one person to next. Scientists can use these variable regions to generate a DNA profile of an individual using sample from blood, bone, hair and other body tissues and products. In criminal cases, this generally involves obtaining sample from crime scene evidence and a suspect, extracting the DNA and analyzing it for presence of a set of specific DNA regions. We call them markers. If the sample profiles do not match, the person did not contribute the DNA at the crime scene. If the pattern match, the suspect may have contributed the evidence sample. DNA from crime scenes also can be compared to profiles stored in database. As regards collection of evidence, the physical evidence is any tangible object that can connect an offender to a crime scene. Biological evidence, which contains DNA, is a type of physical evidence. However, biological evidence is not always visible to the naked eye and may be easily overlooked. DNA testing has expanded the type of useful biological evidence. All biological evidence found at crime scenes can be subjected to DNA testing. A deliberate, methodical, disciplined approach to collection and preservation of evidence is essential. One exception may be if evidence integrity is at risk, and under those circumstances it is important that rapid decision be made to prevent its degradation or loss. It is imperative that the investigator obtain as much information as possible regarding the circumstances of the crime prior entering the scene. Statement from witnesses, victims or first responders can provide a broader understanding of the investigation. The investigator can develop an approach to the scene based on this information and the nature of crime. For example, at the scene of a burglary, attention may focus on the point of entry. Fragments of wood, metal or broken glass may be discovered along with fingerprint, blood and fibers from clothing deposited when the perpetrator forced entry. In the case of a violent crime such as sexual assault, attention may be directed to the clothing and the person of the victim and the suspects. An individual might find body fluid, stains, torn clothing, fingerprint, fibers, hair and other trace material on the areas where attack took place. Potential evidence such as saliva, bite marks, semen, hair, skin tissue under the fingernails and other trace material may be found on the victim. Transferred evidence such as cosmetics, vaginal fluid, hair from the victim, blood may also be found on the suspect. Once potential evidence is located and documented, the next step is to collect and package the item in a manner that prevents contamination, loss and deleterious change. Biological evidence requires care to guard against the possibility of cross contamination either by the investigator or by other biological specimen at the scene. Equipments are available to the crime scene investigators which aid in prevention of cross contamination. The importance of avoiding cross contamination cannot be overemphasized. The investigator performing the collection must ensure tools are clean and sterilized and that gloves are changed between handling each sample. Collection methods differ depending on the type of evidence and the substrate upon which it is found. It is preferable to collect evidence in its original state. If the evidence is fragile or can easily be lost, the entire object should be collected and packaged if size and circumstances permit. While working at the scene of crime, the investigator should use body suit, paper mask that covers nose and mouth, eye protection latex or nitrile gloves, sleeve protectors, shoe covers, hair net to protect himself from infection and to avoid contamination of the exhibits. The investigator should prioritize the order in which evidence is collected. Biological evidence, trace materials and evidence of a fragile nature should be collected first. Collection methods used to gather and package the evidence materials vary. The use of an alternate light source or oblique lighting may be necessary. A sample detected with the alternative light source should be properly packaged with a notation alerting the analyst that it is a luminescent sample. From crime scene to forensic laboratory and then to the courtroom, the inventory of all evidence material should be made and secured to preserve its integrity. Evidence admissibility in court is predicated upon an unbroken chain of custody. It is important to demonstrate that the evidence introduced at trial is the same evidence collected at the crime scene and that access was controlled and documented. The importance of avoiding cross contamination cannot be overemphasized. Investigator performing the collection must ensure that tools are clean and sterilized and the gloves are changed between handling each sample. Collection method differ depending on the type of evidence and the substrate upon which it is found. It is preferable to collect evidence in its original state. If the evidence is fragile or can easily be lost, the entire object should be collected and packaged if size and circumstances permit. For visual collection, on some of the surfaces, hair and fiber can be seen with the naked eye. Using clean forceps and trace paper, the sample can be removed from the surface and placed into clean piece of paper that can be folded and packaged in a paper envelope or other appropriate packaging. Tape lifting is another method. Water or methanol soluble tapes are available for the collection of trace hair and fiber evidence. The tape is applied to the location of the suspected sample, removed and packaged. Vacuuming method is also used for collection of such type of evidence material. The samples are packaged in clean trace paper for submission to the laboratory. Vacuuming is the least desirable collection method because there is a risk of cross contamination if the equipment is not properly cleaned between each use. Investigator should consult the local forensic laboratory and refer to the department standard operating procedures regarding collection and preservation of biological evidence. As regards collection of blood and other body fluids, cutting can be removed from the stained area using sterile or clean cutting device. Another method of collection is wet absorption, where a sterile swab, gauze pad or threads are slightly moistened with sterile distilled water. An effort should be made to concentrate the stain in a localized portion of the swab or pad. For example, when using a swab, the stain should be concentrated on the tip. The collection medium is concentrated into the stain and allowed to dry. Some laboratories recommend following the first moistened swabbing with a second dry swabbing to ensure thorough sample collection. Both swabs are retained and submitted for analysis. Scraping is another method where, using a clean razor blade or a scalpel, the sample is scraped into a clean piece of paper and that can be folded and packaged in a paper envelope or other appropriate packaging. Dried blood stain on non-absorbent surface. Fingerprint lifting tape may be placed over the stain and lifted off. The stain is transferred onto the adhesive side of the tape, which may then be secured on a clean piece of acetate sheet for submission to the laboratory. So, hair and fiber can be collected using vacuuming device, tape lifting, hand picking using forceps with plastic covering on the tip. Reference sample collection. For DNA analysis, reference sample should be collected from individuals who might be linked to crime scene where DNA evidence is found. Reference sample can be used for elimination or comparative analysis. For example, buccal swab samples taken from the suspect or victim in known source should be compared to biological evidence found at the crime scene to eliminate or place them at the scene. Now, type of collection procedures. For collecting buccal swab, sterile swabs or other buccal collecting devices are rubbed against the inside cheek of the individual's mouth to collect epithelial cells for DNA analysis, and liquid blood sample are generally collected in vacuum tubes having EDTA as preservative. Packaging of the evidence material. After collecting the evidence material, their proper packaging should be done. Biological evidence should be dried before packaging to minimize sample degradation. Packaging in paper is preferred. Liquid samples such as water from the toilet bowl or pipes should be properly documented and packaged in sterile glass or plastic container and refrigerated as soon as possible. Documentation of the scene begins with the first responder. Police officers are taught the importance of taking notes from the time of arrival. The crime scene investigator documents the scene in the form of still or video photography. Sketches are completed at the scene to illustrate relationship between articles of evidence not easily depicted by photography. The following method of crime scene documentation are used to provide an accurate representation of the scene. Number 1 is taking note. It is important that the responding officer note down the condition of the scene as it existed upon their arrival. Note taking should be continuously updated during course of investigation. Investigators' note might include such factor as victim and witness statements, who was present at the scene, lighting conditions of open door and windows, odors or smell, sign of activity such as food preparation, date and time indicator such as newspaper or mail, general description of the scene and surrounding area. Photography and videography is another mode of documentation in this. The primary means of crime scene documentation is still photography. Police officers should have an understanding of the importance of keeping the scene preserved and not moving anything until it is photographed. The photographer must be able to testify that the photograph is a true and accurate representation of the scene at the time the photograph was taken. Crime scene photograph should reveal a detailed chronological story of the scene. Sketching is another way of documenting the crime scene, because photographs may not always depict spatial relationship between objects. Sketches are used to supplement photographs. Sketches can more easily depict the overall layout of the scene and the relationship between objects. Investigators usually complete hand drawn rough sketches while at the crime scene. These sketches contain all the necessary information for investigator to subsequently complete a finalized version of the sketch. The table given below shows the various type of evidence, location of DNA on them and the source of DNA. In the first column, the evidence have been shown. In the second column, possible location of the DNA on the evidence is shown, and in the third column, source of DNA is shown. To explain that, suppose evidence is bat or any other weapon, possibility of finding DNA is on the handle and at the ends, and the source of DNA shall be sweat, skin, blood or any other tissue. Another type of evidence can be hat, cap or mask. We can find the DNA inside the hat, cap or mask, and the source of DNA should be sweat, hair and dandruff. Eyeglasses can be the evidence. Nose and ear pieces and lens can contain the DNA on the evidence, and sweat and skin shall be the source of DNA in such cases. Facial tissue or cotton swab can be the evidence, and any surface area on them can contain DNA, and source of DNA shall be mucus, blood, sweat, semen or earwax. Dirty garments if found, the source of DNA shall be blood, sweat and semen on their surface. Toothpick if found, tips can contain saliva, which should be the source of DNA. Used cigarette bidi butts, the saliva shall be the source of DNA. Stamp or envelope, their licked area shall contain DNA. Ligature, inside or outside surface of the ligature shall contain skin or sweat for the as a source of DNA. Bottle, cup or glasses, sides and mouthpiece shall contain saliva or sweat for DNA. Used condom, inside or outside, semen, vaginal or rectal cell shall be present. Blanket, quilt, pillow, sheet, surface area of these evidence, and sheet and hair, semen, urine, saliva shall be the source of DNA on them. Thorough and thorough bullet, outside surface of that would contain blood or tissue as source of DNA. Bite marks if present on the person's skin or clothing, saliva shall be the source of DNA. Fingernails, fingernail scraping shall contain blood, sweat or tissue. Now we come to crime scene integrity. Protection of the crime scene is essential to the protection of evidence. Safeguarding and preserving evidence is fundamental to successful solution of a crime. Remember, while documenting evidence at the scene, to include descriptions of whether evidence was found wet or dry. An example of this documentation would include blood spatters. Contamination. The risk of contamination of any crime scene can be reduced by limiting incidental activity. It is important for all law enforcement personnel at the crime scene to make a conscious effort to refrain from smoking, eating, drinking, littering or any other actions which could compromise the crime scene. Because DNA evidence is more sensitive than other type of evidence, law enforcement personnel should be specially aware of their action at the scene to prevent inadvertent contamination of evidence. Chain of custody. The chain of custody of the evidence is a record of individuals who had physical possession of the evidence. Documentation is critical to maintaining the integrity of the chain of custody. Maintaining the chain of custody is vital for any type of evidence. In addition, if laboratory analysis reveals that DNA evidence was contaminated, it may be necessary to identify persons who have handled that evidence. While processing the evidence, it is better if only few people handle the evidence, and that would lead to less chance of contamination and a shorter chain of custody for court admissibility during the trial. As regards transportation and storage, the first responding officer may be called upon to transport the evidence from a crime scene. As with any evidence, the officer should ensure that the chain of custody is maintained. In addition, the investigator should be aware that direct sunlight and warmer conditions may degrade DNA, and avoid storing evidence in places that may get hot, such as the trunk of the police car. To best preserve DNA evidence, store in a cold environment. Any probative biological sample that has been stored dry or frozen, regardless of age, may be considered for DNA analysis. Nuclear DNA from blood and semen stains more than 20-year-old has been analyzed successfully using polymerase chain reaction. Samples that have been stored wet for an extended period of time should be considered for testing only using PCR and may be unsuitable for DNA analysis. Mitochondrial DNA analysis has been performed on very old bones, teeth and hair sample. Samples generally considered unsuitable for testing with current techniques, including embalmed bodies with possible exception of bone and plucked hair, pathology and fetal tissue samples that have been immersed in formaldehyde or formalin for more than a few hours, with the notable exception of pathology, paraffin blocks and slides. In summary, it can be said that to compare the victim's or suspect DNA profile to the recovered crime scene DNA profile, the laboratory will need to have their own biological samples available for a side-by-side comparison. These known samples are called reference sample. Collection, preservation, forwarding of sample for DNA analysis are equally important. Unless the sample are properly collected and preserved, it will not be useful for investigation. All biological sample need to be carefully dried in shade, not in sun or using any heating device. All biological sample are required to be packed in paper envelope and not in airtight container, so that any moisture remaining in the exhibit goes out of the packet. This would minimize the process of putrefaction or degradation of the DNA material to be analyzed. The skeleton remains should be cleaned and packed in paper envelope and without any preservative. Soft organs should be preserved in dimethyl sulfoxide and not in formalin, which hinders the extraction process as well as PCR process. Thank you.